Hi, welcome to another episode of Kasper On BI. Today, we're going to talk about data engineering. Data engineering is a new term that's been coming up for the last couple of years, and it sounds very similar to what we've been doing in BI and data warehousing for decades. But how is it different? And what does it really mean when they talk about data engineering? Today, to learn more about this, we're talking with Adi Polak, and Adi is a colleague of mine at Microsoft. She works as a cloud advocate in Microsoft under the Azure Engineering Organization, and she specializes in distributed data systems. She used to work as a software developer building infrastructure for data processing and a machine learning researcher. So today she's combining that engineering and machine learning background to educate the community on productizing machine learning and building machine learning models out of big data. So it's pretty fair to say that she's an expert in this area. I hope I'm going to learn a lot today with talking to her. I hope you learn a lot today about data engineering and what it means. I have learned a lot already from looking at her Twitter handle and the tweets that she's been doing, which I will post down below in the description. And with that, let's go over to the session. So, hi Adi, welcome to the Kasper On BI show. It's super exciting to have you here. Can you do a little bit of introduction about yourself?
Yeah, absolutely. Well, thank you for having me, first thing. My name is Adi Polak. I work for Microsoft. I'm part of the cloud advocacy team. I focused on distributed data. And actually, what I do in my job is to help people onboard and learn new technologies and become better using different data services, and also how to improve their career as software developers in technology. And I work closely with open source as well.
Okay, that's pretty cool. So is it, yeah, you said Azure, but it's only Azure or, as you said, also open source, like it doesn't really matter, or mostly focused on Microsoft products?
Well, I am a Microsoft employee, so my day is kind of half between the Microsoft products that we build for people to be successful for their different data tasks,
Mm-hmm.
and also the open source, because there's a very close relationship between the open source and the different services that we build on Azure. We know that we need to provide the availability for people to use their open source on Azure. And also we develop our own open source in Microsoft to support the community with the different tasks that they need to, and the different products that they need to build in order to be successful. So it's kind of like a half-half mixture.
Yeah, I mean, it's actually still a bit of a surprise for a lot of people that Microsoft is doing open source, right? Especially like I've been around Microsoft for like 25 years. In the beginning, is definitely there was no open source, there was no nothing, and now it's much more open source. And I don't know if you worked at Microsoft with Microsoft products before joining Microsoft, but yeah, a lot has changed there, right?
Yes, I actually didn't work with other Microsoft product before. That was an interesting kind of change that I did when I joined Microsoft 2.5 years ago. Because if you would ask me like 5 years ago, I would say, nah, I'm an open source person. It's not going to work. I mean, that relationship
Yes.
with Microsoft, probably not. But then when I discovered about this specific job and how Microsoft is transforming its little strategy and how it works with open source and how the openness of Microsoft and the openness of the various employees in Microsoft towards open source kind of changed this whole perception. And I said, you know what? This is a new Microsoft. This is a new area. So it's definitely something that fits me as a person, and also fits my beliefs and how open source can actually change the way we build software and
Mm.
change the way we help each other as software developers. Because one of the nicest thing about software is you can build an open source framework, an open source solution, and everyone out there can come and give you feedback, can help you, can use your software. So you're not alone. It's not only you in the specific company that you're part of. It's a bigger team. It's global. And I think it's a really nice thing that open source bring to the development culture. And it's wonderful to see that Microsoft is taking such a big part in the open source from providing building different open source for people to use completely for free, having people, hiring people to maintain open source. This is a huge chunk of it. I mean, there are some pretty big teams out there that everything that they do is to maintain open source and build open source. And then myself, who help people use open source in the cloud. I think it's fascinating to see.
Yeah, it's pretty cool. I mean, I remember when I joined Microsoft, it was still Balmer, and it's very different to after Satya came. Really a big change, even in the Power BI team, like the way we worked and the way we did things. A lot has changed in those things. We have some open source things too, but yeah, it's pretty interesting to see. All right, so let's start about data engineering, because that's really I mean, I was looking at your tweets and I was seeing about data engineering, and I think there was a tweet like in the beginning of December about that you tweeted about data engineering, and then I got thinking like, okay, but what is data? I mean, I've been working with data my whole career with SQL Server and store procedures, but it's more organized data, and we didn't call ourselves data engineer. I mean, there was not really a term. So I'm really trying to figure out, what is this data engineering that we keep hearing about?
Yeah, so it's relatively a new term that's still being built inside the industry, and we're going to see a lot of new terms as well, like data architects and such. So to narrow it down, it's mostly about building data pipelines and maintaining the health of data in the organization through open source tools or cloud tools or such. And a lot of people can become data engineers from their current position. So if I see some people work as a backend software developer, or some people work as a data scientist, or some people work as on BI, business analytics and BI tools, and then they kind of slowly do the shifting into data engineering. But what it actually means, it means the data engineer is in charge of the data in the organization, to build the pipelines to make it helpful as well. We know one of the biggest challenges in data is to make sure it's available, especially once it scales up. Also, when we have a product that is geographically distributed, so to make it available to all our customers and all our clients around the world means that we need to think of an architecture that will support that. So that's also some part of the data engineering work, how the data engineers makes the data available for everyone across the world. Also making sure, when we're talking about health of the data, also making sure that the quality of the data is good.
Yeah, exactly.
Like we're testing our software. Yeah, we're testing our software. We're putting it in production after we're happy with the results, but we're injecting data in real time, many times without actually testing it. And so the data quality is one of the main responsibilities of a data engineer, to build the platform or the dashboards to validate this data before we actually inject it into our products. Because many times, and today we see it more and more, many times some of our products are real-time products. It's less about the batch processing, and we're slowly moving forward into the stream processing and the real-time and event-driven architecture and event-driven products. And so if we inject data without qualifying it, a lot of weird things can happen, and a lot of weird things can be shown to the customers that might be not appropriate. So there's a lot of different hats for data engineers.
So
in a lot of different ways.
Can I ask, it's like, so you said, talk about, you said you started out with data pipelines. So that really means you, like, because you're mostly talking about big data, right? Data is being stored in some sort of a file-based system somewhere. And then with the data pipeline, what do you do with that?
Okay, so it depends on my application. I need first to ingest the data somehow. It can be data that I'm capturing a specific customer. Let's say I'm building some log analytics engine, and I need to capture these logs from the customers or from production, and then I need to ingest it somehow into my system, process it, and then show it in a UI or a dashboard or in a report, or make it available for consumption through a REST API, let's say. So the whole data pipeline that can start with gathering the data, ingesting it into our system, maybe running some process on it. And here during the process, we should also think about our governmental, the different governmental ISO or certifications, or if we're working with credit cards. And there's a lot of things that we need to think here or
Yeah,
GDPR,
exactly.
privacy, and we need to think about that as well. So when we're ingesting the data, we need to run some processing on it using different tools. So if we work in the big data space, maybe we want to work with Apache Spark. If we want to process the data that it's more event driven, maybe we want to work with Kafka or other tools to kind of process our data on the fly before we call it sync, before syncing it or saving it to some storage to make, and then later on serving it to other customers inside the organization or for the products. So this is like a very high level of data pipeline, but there's a lot of logic happening underneath that, and the data pipeline can become complex. Depends on the request and what we need, because there's also a matter of enrichment of the data. So let's say I'm pulling data in, or I'm ingesting some data in, and now I actually want to add more fields. I want to enrich the data. I want maybe to extract some data that is not there explicitly. For example, if I'm working with videos, or if I'm working with images or audio, many times I would like to extract some information out of that data. If I work with videos, maybe I see a car in the video, or maybe I want to capture some movement in the video. So this is extra information that I can extract using tools, using different tools, and I will call it my data pipeline, because I'm enriching the data using data pipeline techniques. And at the end, I'm going to get a data, let's say a video, and then the number of cars I saw in the video, or the number of people who moved to the right, just as an example. But it can go various ways. Or maybe I want to clean the data. So this is also a data pipeline. I'm getting some information that I'm not allowed to keep in my storage, so I want to filter it out. So there's a lot of things that can go there. And when I'm building that system, and that depends on the rate that the data is coming, the throughput, the rate that the data is coming into my system, I need to think about how I can accommodate that throughput, especially when I see spikes in the data. So let's say I'm building an e-commerce backend solution, and now it's a special day, and they're doing a special celebration and selling new interesting products. And
Black
now
Friday.
I'm seeing a peak, for example, and now I'm seeing a peak in the input of events coming into the system. I need to make sure my system is stable to accommodate that. So then I need to think how kind of a buffering mechanism in order to process all that data and also not lose it. Because I want to make sure like every event counts. Like every event is a potential customer, an actual customer. If it's an e-commerce and they're now clicked, buy. So I want to make sure I'm not losing all that data. So it's a lot of responsibilities on data engineers when we think about that. But I will argue that today people can become data engineers without coming from a specific area in tech. Because up until now, we saw some data engineers coming from the backend, being a backend software developer, or data engineers coming from the data science part, or the business analytics part. But I will argue that today, with the tools that we have, the open source and also the different tools we have on Azure and on the Microsoft Cloud, we can definitely see more and more people going through the data engineer career path coming from a different background in technology. Just like we saw in web development, a lot of the people became a web developer without necessarily having any background or computer science degree. Cool. So you maybe you want to say a few words about
No,
that.
yeah, I mean, definitely. I mean, there was nothing before that, so we started out by just writing some HTML and some ASP in in text and notepads, and it started showing up in backend systems. And yeah, I mean, it's definitely. But the biggest difference is, I think, I mean, there was not much. Now the change is so rapid. Like it's, and I mean, even for me, like I've been in this space for a long time, but looking at that Azure system ecosystem, I mean, there's just so much stuff, and there are so many tools, and there's so much. Like it's a bit scary, honestly, almost to take a look at. I mean, and of course, it's Microsoft, so they nicely package things for people like me to get more familiar with it, like Synapse, for example, and that feels a bit more comfortable to me because it's what I know. So I mean, and definitely, and even with Power BI itself, I don't know if you've ever seen it, but we have something called data flows too, where you have self-service ETL, but you can run it on a lake with easy tools. So I definitely agree with it, and we're definitely moving into that direction. And the same thing with machine learning. Power BI is doing that a lot too. Like we're trying to put machine learning into the hands of the users. Probably not as sophisticated as an actual data scientist would do it, because they would build their own models. Like we give them pre-built models or let them use the models from the machine learning experts. And then, so maybe not a question that I had for you too is, so we have data engineering. So how is it different than data scientists?
That's a good question, and I recently tweeted that actually data scientists do like 70% of their jobs is building data pipelines. And this is actually that's a great question, because this is actually one I see different companies struggle with. They understand that they need to add more machine learning into their products because they want to make more personalized, smart products. And then they turn into, as a business strategy, they say, okay, I'm going to hire a data scientist lead, and that person is going to build my whole infrastructure for running and building and operating machine learning. And this is not true, because data science, most often, they're expert on statistics, and they expert on the machine learning algorithms, how to use them, when to use them, how to evaluate. So, but they're not expert on software development, and then they don't know how to build the infrastructure to enable that machine learning to run at scale in production, or to build a platform for themselves to create sophisticated machine learning models. And this is where data engineers comes to play, because the data engineers, as an engineers, they know software development basics, they know how to operate software at scale, and they can build these pipelines that the data scientists don't need to build anymore. So the data engineers are going to build the data pipelines to ingest the data, support also feature generation and feature engineering scientists used to do up until now, and kind of help speed the whole process of actionizing machine learning inside the organization. So there's two ends to the machine learning lifecycle. There's from the data coming in, ingesting into the system. We work through feature engineering, building the module, and then serving that machine learning module in production. This kind of whole stack was split into three parts. So we have the data engineering in the beginning, ingesting the data, helping with the scalability of the data, helping with the feature engineering of the data from an engineering side. And then we have the data scientists who are expert on machine learning, and then they're building the sophisticated algorithms to produce great machine learning models, state-of-the-art machine learning models. And then we have the AI or machine learning engineers who help to deploy these models in production in a scalable manner, and also help to monitor this machine learning models in production, because we know now that we have to change them. I mean, it used to be like you build one machine learning model, that's great. You can keep it in production for a whole year until you get the second version. But now we realize that you have to change it because the data being ingested into the system is changing. So there's need to be a communication between the machine learning engineers actually in charge of the data, in charge of the machine learning model in production. The way they monitor it should be very close. They should work very closely with the data engineer on the new data that gets into the system.
Yeah.
So this is kind of how I see it between the different world. But again, it depends on the size of the company. If there's a small startup and they have 10 people, for example, including the founders, then most likely a lot of people are going to wear a lot of hats and do a lot of the things on their own. But if it's a big company with 1,000 people, then most likely we will see for the data engineer, a dedicated department for the data scientists, and a dedicated department for the machine learning engineer. They all should kind of work together to build this pipeline. So it depends. So going back, it depends on the skills that they bring to the table. Data engineers are more engineers or more software developers, versus data scientists are experts on statistics. They're expert on how machine learning algorithms built. They're experts. Sometimes they will be domain expert. There's some data scientists that have that specialize in some domain, healthcare or security for Windows machines, for example, or anything like that. And then we have DAI engineers who know how to take it and later on scale it. Sometimes, like you mentioned, like the thing we have with Power BI, you don't always need to have sophisticated machine learning algorithms or sophisticated machine learning modules. So then maybe you can kind of think how you can bring a domain expert into the table and say, you know what, I'm going to use this built-in machine learning module that Microsoft already provide me through some, cognitive services. And I'm going to use it for my specific need because I'm familiar with the data domain. I know how this domain works. So I know which machine learning I need to use, but not necessarily I'm expert on how to build it myself. But I can build something that it's already someone else built it for me, and I can inject it into my system. So again, it depends on. Sorry, going back to your question, it's different set of skills, and also it depends on what the company needs. I mean, do you need a data engineer? Do you need a data scientist? Can you leverage what exists in the cloud?
Yeah, and probably the way I see it today too, there's so much data that is sitting there, and I mean the stuff that you can get out of it and learn from it, it's pretty amazing. But you do need the skills, obviously, because even today, like there's so much data sitting away in SAP and in SQL Server databases, tons and tons of data that it's really hard to get access to from any of these tools. You really need them, at least that's what I think. You need to move them to a different location, like where you can run those machine learning algorithms over it. Is that true? Or can you just keep them in the SQL Server database and run them over?
I think it depends on the team and how you build the infrastructure. So today, let's say with Azure Synapse, there are multiple connectors. So you can connect your data from SQL Server or from, either if it's on GitHub or if it's on AWS S3 or the Google Cloud, you can ingest this data into Azure Synapse and process it there. And then you can decide what you want to do with it. If you want to serve it, if you want to give it to the domain expert, the data scientist, business analyst in the organization to process that data and build beautiful dashboards using Power BI, for example. So it really depends on the people, the skills, where this data lives, and also the different compliances you need to adhere to when using that data. If it's a healthcare data, then it's a whole different conversation.
Of course, yeah.
Of who can use it, where, which country, and so on. So yeah, I think we don't necessarily need to move our data if we're happy with where it is. I do know that some people are moving their data to save costs. So it's a function of how much it costs me to save that data in a specific place. Maybe if I'll shift it, I can save a bigger chunk of the data in cold storage because I don't need to have it. So cold versus hot storage. Cold is the storage I don't necessarily need to have access on the fly versus hot storage that I needed to constantly be available. So maybe I can shift it into a cold storage and then kind of read from it when there's a new feature or a new product that I want to test. And I want to use that data to test it. Or something like that, or some new report that I want to use. And now I need this data from 2005 because I want to check something.
Yeah. So
So this can,
what would a day look like as a project for a data engineer? So what are some of the tasks really physically that they're actually doing? And like there's application lifecycle management. So do they check in with GitHub and they have version control and things like this too?
yeah, they're software developer to, they're a software developer, point blank. Even if they're building complex SQL queries, they still need to have version control. They still need the CI. If they work in CI/CD, they need to have the CI/CD pipeline there as well. The different reviews on the SQL queries that they write. So this is if they do SQL. If they write code, then they develop code, let's say using Apache Spark or Apache Kafka, then yeah, it's the traditional software engineering life cycle as well.
And so actually that kind of brings me to another question. Like when you're doing one of those projects, like there's so much choice. Is it usual that they decide for a particular project, oh, okay, I'm going to use Python, or I'm going to use SQL, or I'm going to use whatever it is? Or is it usually the case that every individual developer thinks, oh, no, I use R, so I want to use R? Is because I can imagine in the reviewing process that's pretty hard because you don't know everything.
Yeah, it kind of reminds me the challenge that microservices had a few years ago when they said, hey, I'm building a microservices. I can build it in whatever language I want as long as I'm giving people the ability to consume or to use my microservices, right? I think it goes back to the culture of the team. If the culture of the team saying, we're going to work with a specific programming language or we're going to work with this specific tool, then everyone in the data engineering tool should work with that specific tool. And unless there is some exceptions, like some tools are going to give us better results, and it makes sense that half of our workload, for example, we should do with this tool, and then it's a whole negotiation with the data architects and the tech leads in the team to think together if this is an open source or this is a new service that. But having an kind of looking from the top, then thinking of data engineering in more general and not on a team, on a specific team, then data engineering can have SQL capabilities. They can write in Python, they can write in Java, they can write in Scala, they can write in .NET. So it doesn't matter where you're coming from.
Yeah.
As long as they can use the tool. I will say on that note, though, that I did see a lot of people coming from databases background, and they tend to use Python more than Scala or Java, just because it's easier and faster to learn.
Yeah.
So a lot of people that are writing SQL queries, and this used to be their bread and butter, are now going to onboard or boarding themselves into how to work with data using Python. So this is like one area that I will say, if you're coming from a SQL, maybe you should look at Python. But if I don't want to limit anyone, so if you want to go .NET or if you want to go into Java, then go for it. This is a decision that comes from that's in the team and from the architect on which languages to use to build a product.
Cool. So yeah, so maybe that is a nice segue too into you kind of already started talking about this, but so let's say I'm a traditional Microsoft person. I've been working with Microsoft products, SQL Server, .NET, ASP, and probably most of the people that I work with in the Power BI organization and the larger, like even our customers and our users are also in that same boat. But what if I want to go into the data engineering world? What should I learn and where should I go to learn them?
So you're coming from a Microsoft background?
Yeah.
Okay. So software development, .NET, SQL Server,
Exactly.
that's kind of the area. So I think you're already in there. I mean, it depends on how you can build a simple SQL query that will pull data from one table and then will sync it and save it into a completely new table. There you go. You build a data pipeline. You're doing data engineering work. You can do it with .NET. With .NET also, there's a lot of extensions. I know now they released the Apache Spark for .NET, so you can work with Spark using .NET. So there's no limits there.
But I think so. Maybe taking
And also,
one step back. So I store the data in an ADLS, probably in Microsoft World, ADLS Gen 2. And then there are so many options again, what to choose and how to go for it. So you would probably like, should I learn Python, or should I just stick with the SQL, or it doesn't really matter? And which tools should I use?
Yeah. It depends. It depends on the logic, and I'll explain. So you can use SQL, right? You can go to Azure Synapse and use the built-in serverless SQL and write whatever you want on the data in your data lake in your ADLS Gen 2 and process it, and then later on save it into a table or save it into Synapse. You can also say, you know what, I want something more complex. I want to consume this data and run a complex processing on it that SQL doesn't give me, necessarily it's available for me, or maybe SQL is too complex and I know how to write code. So I can open Spark Pool in Azure Synapse or Azure Databricks and process that data and later on save it into some storage or into a database, whatever I want to do with it. So this will be my data pipeline. And we have a variety of tools. So we have HD Insights that enable us the HDFS and the Hadoop ecosystem. So we can run Apache Spark and Kafka and a lot of other things there. We have Azure Databricks that enable us to run complex Apache Spark workloads. We have the Azure Synapse, who also enable us to have the SQL Serverless built-in, who has Apache Spark built-in, and other different pools that you can use on demand as well there. There are other tools, I know with the Power Platform, there's some new tools on data capturing and data processing that you can build with the no-code, low-code approach, where you read the data from the ADLS Gen 2 and you can process it and then show it in some UI or sync it to some database. You can also go fully open source or cloud native, where you can deploy your own, let's say, Apache Spark or Flink or Kafka or whatever favorite processing framework, or even just one app that do some processing on AKS, Azure Kubernetes Services. Read the data, process that, sync it, save it somewhere. So there's a lot of tools, and it really depends on, are you doing it in real time? Are you doing it in batch processing? How big is your data?
What's the use case? What's the end goal? Like, what's the end goal?
What's the use case? Also, what's your main workload? If you come and say, hey, all my workloads, I work with Apache Spark. How will this workload fit into Apache Spark? Do you really need to have a totally new framework and bring that new knowledge to the team, or can they use the knowledge that they already have in the team to create this new workload? So that depends on that. It depends on the scale. Sometimes, let's say with Synapse, you can use the Azure Serverless SQL, but maybe you want to have your own pools that you're controlling. You don't want to have the serverless approach. You want to have something. You want to build something that is. You want to build a workload that is a scheduled workload that runs every hour, let's say. So maybe you want to go with a different approach. Maybe you want to work with your dedicated pools or dedicated Spark pools and make this, build this process and then schedule it. So again, it depends on the workload. It depends on what you need. And also what your team knows. It's always amazing, because people think that it's easy for software engineers to learn software. Well, nothing is easy. It takes time to learn software. Even if that's like a cloud service that is super well built, intuitive, or an open source that is super well documented, it still takes time to onboard a team into a new software that they're going to use, into a new framework. So this is another consideration of what you're bringing into the table. If they know it, they don't know it. If you're gonna go through the process of onboarding them.
Maybe that brings us to another question that I was thinking about. Like, So let's say I'm going to start a new project and I have some data already sitting somewhere, but like, do I want to choose like how am I going to go to traditional approach or like traditional pipelines and just from SQL to SQL, and this is how we used to do it, right? The ETL, like we had the database that had the raw data, and then we had a database that had some better data, and then we went to the data warehouse, and then we did some stuff with it. But why would I want to leave that old world, the world that I know, to go to the new world? Like what are some things that I couldn't really do? I have some ideas myself, but I want to hear you say it. But what are some of the things that I can do now that I couldn't do before?
So it depends where you're coming from, but it depends mostly. Sometimes it used to be accessibility and the level of knowledge you need in order to use that specific data. So maybe you need a DBA to pull or extract or work with some complex databases that you have. And you have to have someone who is writing this store procedures, or some things that are more complex than what we have today with the different products. Or sometimes in the past the performance wasn't good. So we want to have things that are faster, smarter, well connected.
Well, it's probably like
So
in
you
that
want to
case,
go with that.
probably the serverless is like massive, right? If you have data at larger scale and you can just throw CPU at it, I mean, we didn't have that. You just had to buy a bigger server and a bigger server.
Yeah, and it costs. I mean, it adds complexity, adds costs. And this problem still exists. I mean, sometimes you can't move your data just because of the regulations, and it's fine. The serverless, of course, it's the new thing that a lot of people like, because now you can run SQL on data that it's not stored in any database.
Yeah. And then I think maybe the other good, interesting thing here is that we didn't have really before. And I think we're just starting to scratch the surfaces. But as you mentioned before, like the adding of the machine learning algorithms and whatever you can learn on your data and enrich the data with like I remember we had an add-in in an analysis service a long time ago that allowed us to do market basket analysis and things like this. But that was you had to set it up in certain ways and you had to do it in certain ways. But now it feels like it's much easier, if you know what you're doing, to do these types of things on top of your data. And of course, it's very valuable for any e-commerce platform or something like this. Is that right?
I think it is, and it's also today more tools comes with a nice UI, which is a great plus in my opinion, because you don't necessarily have to be an expert on command lines, and you don't need to be an expert on writing scripts. You can use the UI to do that. You can kind of pull different images. I want this machine learning, and I'm going to build my pipeline from some icon that I pulled, that this is now my machine learning model that I'm going to use. Definitely simplifying it, which of course increase the amount of people that can start building smarter products, which is wonderful, especially now when we're in the midst of COVID-19 and a lot of people, unfortunately lost their jobs. And now there's this high tech is booming, and in a good way, and people can onboard themselves, and they don't need to be experts on scripts, and they don't need to be experts on writing code. They can use the no code low code approach and build beautiful products and extract great insights and run data analytics, and use machine learning for their data analytics without writing code. So I think this is one of the greatest advantages that we have, because we're basically saying, if in the past software engineering or building software used to be kind of a closed group, now with the no code low code, we're saying, you don't need to have dedicated degree. You can come in and explore the UI, play with it a little bit. It's much nicer than saying the command line code. It's easier to track also for humans. It's easier for us as humans to track a nice, well-built UI and do that. So I think it's a great change in the world, especially now. And so it takes me to Microsoft initiative of scaling up 1 billion people and help them create products and produce
Mm-hmm.
software without necessarily writing code.
Yeah, yeah.
So I think it's joking.
And then, so again, come a little bit back to the question of getting started. So, are there some resources at Microsoft that we have for people to want to get started? Like, is there anything you can point us at?
Yes. A very short blog post on becoming data engineer, which is going to split it into areas.
All right. I will
So
put it in
I'll share the link with
description.
you.
Yeah.
Awesome. And in Microsoft, we have the Microsoft Learn and also the Microsoft Skill Up initiative. So on Microsoft Learn, you can come and take any learning path that you want, and there's a dedicated learning path on how to become a data engineer and what is data engineering using the Microsoft tools. So you don't necessarily need to have any, prerequisite or any skills as a software developer. And also we have the skilling initiative where Microsoft basically kind of open source different LinkedIn learning paths and also GitHub. On GitHub, there's also learning paths as well for people to come and learn completely free, which I think is wonderful. And there's also the certification. So Microsoft for different products that we have and for different paths, career path, we have dedicated certifications. And so you can learn on your own and then take the certification exam. The certification exam usually costs money,
Yeah.
but there is a scholarship that you can apply to. Win a free certificate voucher exam to kind of to do the exam and get the certificate. So you'll have something to show on your CV or when you're applying for a job saying, hey, I know this technologies, I have the certificate. Yeah.
Oh, that's good.
So,
I mean, actually, we
definitely.
we have the same for Power BI. In that same learning, there's also Power BI that you can take too. So yeah, it's good. All right. And so
yeah.
Maybe not one of the last questions, but what's going on? Is there anything new and exciting happening in this area that we need to know about?
New and exciting. So recently we see more and more the conversation on feature stores, and this is part of the machine learning life cycle that data engineers takes part in, and how to build the features specifically and make these features available for both production and during the time when we build machine learning modules. So this is an interesting conversation going on. There's a few startups that raised since then and a few services and features that different clouds are serving now. So this is an interesting topic to know about. Another interesting topic, and I touched it a little bit, is the complex data. And the complex data is videos, audio, images now they have an answer. So people looking into ways on how to process videos better, specifically how to capture state from video to video, because video is a collection of frames, which are collections of images.
Yeah.
And also audio. There's a new kind of a social media place that is built on audio that I now completely forget the name, but I will share it with you so you can have it on the description. And it seems like it's growing, and it's interesting to see because we used to have Twitter that's mostly text. We used to have Instagram where it's mostly pictures, slightly images and stuff. LinkedIn is professional social media platform, and now we have an audio based social media platform, which means it's another type of data we can support.
Yeah, I can. I'm trying to think about how that would look like. You need pretty big processing power to be able to crack this thing open and get some, and probably a lot of metadata comes out of it too, or a lot of data.
Yeah, think about the analytics part. I mean, there's so many audios, and now you can have one system to run analytics on this audio, kind of categorizing different audio and recommending.
I mean, I'm trying to think about use cases too, but I definitely think, like, for example, video is pretty amazing if you just have your video of your store running, and you can see how people are walking in your store and what they're doing and what they're grabbing, and like that's pretty amazing. I remember seeing
Yeah.
I remember seeing the Amazon store in Seattle, where you can go in and you can just get whatever you want, and you walk out and you just automatically get a bill from from Amazon saying, "Oh, you bought all these things." That's pretty amazing.
Yeah, it is. It is. It's amazing, and it's going to grow. I think it's going to grow. We will have from videos. We'll have the autonomous driving and autonomous drones. From audio, I'm still looking to understand. Except for Spotify, I couldn't really figure out where the business is going towards.
Mm.
But I think Spotify is doing a great job. But maybe with I don't know, different calls or podcasts or anything like that for people. We'll see.
Yeah, that's interesting. So maybe one of the last things is, so what would you tell any data engineer? What are some of the tips and tricks that they should keep an eye out and do and or not do?
First of all, don't jump necessarily into new technology if you don't necessarily need it.
Mm-hmm.
This is one of the kind of the best practices for all software developers. There's a lot of things that are hyped and look shiny, but many times they're not ready yet, and that's fine. It takes some time, especially with open source. It takes some time still. The open source became stable, and you can use it. So don't worry about the hype. It's fine. Second thing is be patient. Sometimes some open source, some tools can be more complex, and that's okay. Start small and then iterate and grow. And third thing, it's okay to fail. Everyone's failing. It's okay if your data pipeline is not the best. If it fails on specific load, you will improve it, and it will become better, and you will know how to make your data pipeline. Thing is continue learning, always continue learning, always continue to exist. Even if you don't use it, it's always good to know that it's there just in case one day you have a new data pipeline that you need to build, and you can and it's something that you never seen before, but you'll have some previous knowledge of tools that exist in the market.
And then, so what is a place that you go to learn about these things? Like for me, I pick up things on Twitter. Like that's how I came across your profile too. Like, yeah, I just pick them things up there. Is that the same for the big data world and the machine learning, data engineering?
Yeah, I recommend finding the people that writes about that on Twitter and following them and engaged in conversation. So feel free to ask questions. I think that's the biggest catalyst for learning is to ask questions.
Yeah.
So ask questions, ask why, ask when, ask how, everything that you can. I know that there's a data engineering channel. There are some weeks that it's more active, some weeks that it's less active. I'm personally going in there to answer questions if I see some questions that I can answer. So Twitter and Reddit, I think, are good places to learn and be part of the engineering community.
Cool. All right, thanks. So maybe any last words that you want to share?
Engineering is exciting. As a person who comes from a machine learning background, I jumped into data engineering, and I think the algorithms and the tools and everything is super, super exciting. So, if that's something that you're passionate about, just do it.
So thank you very much. What I will do is, as you said, I'll put all the links in the description so people can start playing around with it, and your Twitter profile. So you can ask Adi questions on Twitter. You can ask me questions on Power BI, not on data engineering. Yeah, thanks a lot for your time, and it was great to have you here. Thanks a lot.
Thank you, Kasper.
And that concludes another episode of Kasper On BI. I hope you've enjoyed it. I've learned a lot. I hope you've learned a lot too. If you like these episodes, please hit the subscribe button or listen to us on the podcast, available on Spotify and Apple. And with that, I'll see you next time.